Hello learners, welcome to Constant Learners. In today's video, we are discussing the Boyce-Codd normal form. We've already completed with the first, second and third normal form, and Boyce-Codd normal form is at the topmost level in all the levels of database normalization, right? Now to understand Boyce-Codd normal form, we need to know what is normalization, what is third normal form, and what are trivial and non-trivial functional dependencies. I've already explained all of these three concepts in three separate videos. I'm going to share the link of all of these videos in the description box below. So if you don't know any of these concepts, I would request you to please watch those videos first, right? Trivial and non-trivial functional dependencies we'll discuss in short in this particular video as well, right? Let's get started. Now, Boyce-Codd normal form was developed by Raymond F. Boyce and Edgar F. Codd. Until now, first, second and third normal forms were developed by just Edgar F. Codd because he is known as the father of database management system. But this one has been developed by both of these people. It is an extension of third normal form. Why an extension? Because it is based on third normal form. Alright. Boyce-Codd normal form is at the topmost position where almost all of the redundancies related to functional dependencies are removed. That means any redundancy that comes up because of the functional dependencies are removed at the Boyce-Codd normal form, right? Why? Because any table which is in the BCNF is also in third normal form, it is also in second normal form, it is also in first normal form, right? And until now, all the redundancies related to functional dependencies are removed, right? Now, there are two rules for a table to be in Boyce-Codd normal form. First one is that the relation must be in third normal form. And we know that for a table to be in third normal form, it should be in second normal form and there should be no transitive dependencies, right? Now in Boyce-Codd normal form, the relation must mandatorily be in third normal form. And the second rule has two parts, right? And that depends upon trivial and non-trivial functional dependencies. Now, what is a trivial functional dependency? See, the functional dependency X determines Y must be a trivial functional dependency. That means the first rule is that the functional dependency mentioned for that particular table must be a trivial functional dependency. Trivial functional dependency means what? That means Y, which is the dependent. Y is the dependent here, right? So the dependent must be a proper subset of the determinant. So this is our determinant, right? So the first rule of the second rule is that the functional dependency X determines Y must be a trivial functional dependency. That means the dependent must be a proper subset of the determinant. For example, let's say X is equal to student ID, name and department. Okay, this is X, that is our determinant, and Y is the name, right? So now Y is the proper subset of X. So dependent must be a proper subset of the determinant. That is trivial functional dependency. So to be in Boyce-Codd normal form, the table must be in third normal form and, I'm saying and, along with being in third normal form, the functional dependency must be a trivial functional dependency, right? Or if it is not a trivial functional dependency, that means if Y, that is the dependent, is not a proper subset of the determinant, then in that case, the rule is for every non-trivial functional dependency, that is where Y is not the proper subset of X, in that case, left-hand side, that is the determinant, must be a candidate key or a super key. This is a fixed rule that if it is a non-trivial functional dependency, the determinant or the left-hand side must be a candidate key or a super key, right? For second normal form, the rule was that there should be no transitive dependency. That is, no non-prime attribute should determine another non-prime attribute, right? This was not allowed. Then the second rule was that if right-hand side was a prime attribute, it didn't matter what was there on the left-hand side. It could be a non-prime attribute or it could be a prime attribute, right? But if right hand side was a prime attribute, then it was in the second normal form. Or we had an or here, right? This is an or left hand side could be a super key or candidate key, right? So we had this or for third normal form. But in case of Boyce-Codd normal form, there is no or. There is just one rule that for every non-trivial functional dependency, left-hand side must mandatorily be a candidate key or a super key. For Boyce-Codd normal form, this rule that right-hand side is a prime attribute is not applicable, right? For Boyce-Codd normal form, these rules do not apply. That is non-prime attribute determining another non-prime attribute, or right hand side could be a prime attribute. All of these rules do not apply for Boyce-Codd normal form. There's only one rule, that either the functional dependency should be a trivial functional dependency, and if it is not a trivial functional dependency, then left hand side must definitely be a candidate key or a super key, right? I hope that this was clear. Now let's take a simple example. We have a table wherein we have attributes A, B, C, D and E, right? The functional dependencies given are A determines B, C and D, then C determines E, and E determines A. These are the functional dependencies, right? Now, if we take the attribute closure of A, what do we get? A will determine itself. It also determines B, C and D. Then C determines E. So we are getting all the attributes here. Hence we can say that A is the super key, right? And A will also be the candidate key, because there's no other proper subset of A that could be a super key. So it is also a candidate key. Now A can be determined by E, right? So E will also be a super key. And since there's no proper subset of E which can be a super key, it is also a candidate key, right? And since E is determinable by C, C will also be a super key and a candidate key, right? So we've got three candidate keys here. The prime attributes will be A, E and C, right? Now, for a table to be in Boyce-Codd normal form, it is necessary that left-hand side for all non-trivial functional dependencies are candidate keys or super keys. Let's check that. In this functional dependency, left-hand side is A, which is a candidate key. In this functional dependency also, C is a candidate key. That means left-hand side is a candidate key, and E is also a candidate key. Hence, we can say that this table here is in Boyce-Codd normal form. Now, in case there was a functional dependency, B determines D, right? So, B is a non-prime attribute and D is also a non-prime attribute. So, this table would not have been in third normal form also. So, it definitely would not be in Boyce-Codd normal form also. And thus, we conclude that in Boyce-Codd normal form, all the redundancies related to transitive dependencies are eliminated. All right. I hope that Boyce-Codd normal form was clear. This is all that is there in Boyce-Codd normal form. The only important factor is that in third normal form, there were three conditions for a table to be in third normal form. First one was that non-prime attribute cannot determine another non-prime attribute. Then second condition was that if right-hand side was a prime attribute, it was in third normal form. And if left-hand side was a super key or candidate key, it would be in the third normal form, right? But these two conditions were in or, that is right-hand side is a prime attribute or left-hand side is the super key or candidate key. But in case of Boyce-Codd normal form, there's only one important condition for non-trivial functional dependencies, and that is the left-hand side has to be a candidate key or a super key. There's no condition saying that right-hand side could be a prime attribute or not. It does not matter whether right-hand side is a prime attribute or not. But left-hand side definitely has to be a super key or a candidate key. And if that is the case for non-trivial functional dependency, then the table is automatically in Boyce-Codd normal form. I hope that this was clear. If you have any doubts or any queries, you can always write them in the comment section. If you like this video, if it was helpful, don't forget to give it a thumbs up and subscribe to the channel for more such videos. Thank you so much for watching.